Chapter 18 described the regulator as a learning system. Chapter 19 takes the next step and asks how that system should be designed. The problem is familiar. Supervisory authorities say they want outcomes, but the instruments available to them usually describe activities. A committee met. A policy was updated. Training was completed. A review occurred on schedule. Those activities may be necessary, but none of them proves that the public outcome was protected. An organization can perform every required activity and still fail at the boundary where customers, citizens, or market participants depend on it. This chapter shows how to redesign the supervisory conversation around that boundary. It uses the 7 minimum viable capabilities in QOQM trees to connect statutory intent to operational evidence without discarding existing law, guidance, or supervisory authority. The goal is not lighter regulation for its own sake. The goal is more credible regulation. A regulator should be able to see whether the system can perform under difficult conditions, whether evidence changes decisions, and whether learning reaches the rulebook before the next crisis forces the issue. The opening slide contrasts two objects. On the left are stacks of forms, reports, attestations, and control descriptions. On the right is a living system of boundaries, capabilities, feedback, and adaptation. Both matter, but they perform different jobs. Documents preserve intent and provide accountability. The living system produces the outcome that the public experiences. Outcome-based regulation begins by refusing to confuse those objects. A completed form can show that a process was followed. It cannot, by itself, show that a payment service will remain available during a supplier failure, that a hospital can continue delivering care during a cyber incident, or that a public benefit system can handle a sudden surge in demand. Those claims require operational evidence. The central design move is therefore simple to state and demanding to execute. Start with the outcome that must be protected. Locate the boundary where that outcome becomes observable. Define the capabilities needed to keep the boundary working. Then ask for evidence that those capabilities operate as a connected system. The paperwork remains, but it becomes a trace of that system rather than a substitute for it. This slide shows the compliance distortion as an imbalance. The volume of artifacts outweighs the evidence of actual system behavior. That imbalance does not usually arise because regulators prefer paperwork. It arises because activities are easier to specify, compare, and enforce. A supervisor can ask whether a policy exists and receive a yes or no answer. Asking whether a firm can protect a critical service under severe disruption requires judgment, context, and evidence gathered over time. Once activities become the default tool, behavior follows the measurement. Firms invest in what can be demonstrated most easily. Compliance teams build document production systems. Supervisors receive increasingly polished submissions. Operations teams learn that the official test is whether the artifact can be produced, even when the real system depends on workarounds that the artifact never reveals. The United Kingdom operational resilience regime offers a useful contrast. The Financial Conduct Authority requires firms to identify important business services, set impact tolerances, map dependencies, and test whether those services can remain within tolerance during severe but plausible disruption. The regulatory focus shifts toward the services experienced by customers and markets, not merely the existence of a control catalog. The approach is not identical to DVMS, but it demonstrates the same design principle. Supervision becomes more meaningful when the unit of attention is an outcome-bearing service under stress. The distortion begins to reverse when the supervisor asks a harder question. Not did the firm perform the required activity? Instead, what changed in the system because the activity occurred, and what evidence shows that the protected outcome is now more likely to hold? The diagram on this slide captures the new unit of design. Statutory intent flows first to real boundaries. At those boundaries, QOQM trees express the outcome and its evidence, while the minimum viable capabilities describe the organizational capacity required to produce it. The result is a supervised outcome that can be discussed, tested, and challenged. This changes the drafting question. Activity-based rules ask what firms must do. Outcome-based design asks what must remain true for the people and systems the statute protects. A rule requiring annual continuity testing may generate a test report. A boundary-based outcome might require customers to continue accessing a critical service within a defined tolerance during a severe but plausible disruption. The second statement creates a stronger design problem because it forces the firm to connect technology, people, suppliers, decision authority, and recovery behavior. The pivot does not eliminate prescription. Some activities will remain mandatory because experience has shown that they are necessary. The difference is that activities now earn their place by supporting a stated outcome. That relationship makes it easier to detect obsolete requirements and harder to hide missing capabilities. A requirement that produces no useful evidence or learning becomes visible as administrative weight rather than protection. The matrix compares two supervisory postures across 4 dimensions. The first is focus. Activity-based supervision examines generic enterprise policies. Outcome-based supervision examines specific value stream boundaries. The distinction matters because generic policies can be correct, while one critical interface remains fragile. The second dimension is evidence. Static artifacts and point-in-time attestations describe a condition at a specific point in time. Active QOCA measures and loop traces show whether the condition persists and whether the organization responds when it changes. The third dimension is expectations. A rigid list specifies activities. Minimum viable capabilities specify what the organization must be able to do, while allowing it to choose an implementation suited to its scale and architecture. The fourth dimension is accountability. Passive compliance execution allows an entity to say that it followed the prescribed steps. Active system ownership requires the entity to defend its design. It must explain why the chosen measures are sufficient, how weak signals are detected, who can act, and what evidence shows that learning altered the system. This matrix should not be read as a demand to abandon checklists. Checklists remain valuable where the task is stable, repeatable, and well understood. They become dangerous when used as the primary assurance method for a dynamic system. The test is whether the checklist describes a known procedure, or is being asked to stand in for evidence that a complex outcome will hold. The 5-step architecture turns the paradigm into a repeatable design method. Step 1 anchors regulation at real boundaries. Step 2 expresses intent through QOCM structures. Step 3 specifies the minimum viable capabilities needed at the boundary. Step 4 requires firms to own their evidence. Step 5 supervises feedback loops rather than isolated snapshots. The order matters. If a regulator begins with capabilities before naming the boundary, the capabilities become generic maturity statements. If it begins with metrics before defining the outcome, the measures become a dashboard searching for a purpose. If it demands evidence before allowing the firm to explain its operating model, the regulator recreates the template burden this architecture is intended to avoid. Each step also constrains the next. A clearly named boundary limits the outcome to something observable. A clear outcome limits the metrics to evidence that can change a decision. Capability expectations limit the conversation to the organizational functions needed to produce that outcome. Firm-owned evidence reveals whether those functions operate in the real architecture. Loop-based supervision then tests whether the whole arrangement learns. This is not a 5-stage implementation project that ends after step 5. It is a design cycle. As evidence changes, the boundary definition, outcomes, measures, or capability expectations may need to change accordingly. A statute usually states a broad public purpose: protect consumers, maintain financial stability, safeguard health information, ensure fair access to essential services. Those purposes are legitimate, but they are too abstract to supervise directly. A boundary is the point where the purpose becomes observable. The examples on the slide make that concrete. A customer-facing checkout is where a small business accepts payments. A settlement interface is where obligations between institutions either clear or begin to accumulate. A claims intake portal is where citizens, after a natural disaster, encounter the public promise of assistance. Each boundary connects a protected outcome to a real interaction. The UK approach to important business services shows why this move is powerful. Firms must identify distinct services whose disruption could cause intolerable harm or threaten market integrity, and then set impact tolerances for each service. The regulator does not begin with an inventory of servers or policies. It begins with what the customer or market depends on, then works backward into the supporting people, processes, technology, facilities, information, and third parties. Boundary selection requires discipline. A boundary that is too broad becomes another slogan. A boundary that is too narrow can optimize one component, while the end-to-end service fails. The right boundary is specific enough to observe and important enough that its failure would matter outside the team operating it. Once the boundary is named, statutory language must be translated into a structure that can guide action. The question of outcome states what must remain true at the boundary. The question of metric identifies the minimum number of observations and tests needed to determine whether the outcome is real. The settlement example begins with a public intent. Critical settlements are cleared within agreed-upon time windows, even during disruption, so systemic stability is preserved. That outcome then branches into implementer questions and auditor questions. The implementer asks how continuity will be maintained. The auditor asks what evidence would demonstrate that the continuity claim holds. Measures such as maximum acceptable delay, contingency queue thresholds, and sampling verification rates make the conversation operational. A useful QOQM tree does not attempt to measure everything. It selects measures that can trigger a decision. A latency measure matters when crossing the threshold changes routing, escalation, capacity allocation, or customer communication. A queue measure matters when it activates contingency processing before the backlog causes wider harm. A metric that never changes behavior may still be interesting, but it does not carry the assurance load. The structure also makes disagreement productive. A firm may argue that the regulator proposed the wrong threshold. A supervisor may argue that the firm omitted a critical branch. Those disagreements now concern an explicit model of the protected outcome. They are easier to test and improve than a dispute over whether a policy contains the expected language. The 7 capabilities surround the boundary outcome because no single control produces resilience. Govern sets acceptable conditions and decision authority. Assure tests the evidence. Plan prepares for foreseeable stress. Design creates patterns that can operate under that stress. Change protects the outcome while the system evolves. Execute performs the work in real conditions. Innovate creates a guarded path for testing better approaches. The word minimum is important. The regulator is not describing an ideal organization or demanding identical maturity across every function. It is identifying the smallest complete set of capabilities that must be present for the outcome to be plausible. A firm may have excellent recovery technology, but if govern has not defined who can invoke it, the capability is incomplete. A firm may run drills, but if change never updates the design after a failed drill, the loop remains open. Capability-based supervision is also more proportionate than identical control prescription. A global bank and a regional provider may protect the same customer outcome through different architectures. The regulator can hold both to the same capability expectation, while allowing the design to reflect scale, concentration, and technology. The question is not whether both firms bought the same tool. It is whether each can demonstrate the capability that the outcome requires. This posture places a greater burden on supervisory judgment. Examiners must understand the mechanism, not merely locate the artifact. That is a real cost. It is also the price of receiving evidence about the system rather than evidence about document production. Step 4 changes who solves the design problem. The supervisor defines the required outcome and challenges the sufficiency of the capabilities. The firm explains how its own system produces that outcome and presents the QOQM evidence that supports the claim. The slide contrasts a global bank with a regional provider. Identical controls can fail both organizations in different ways because their architectures, suppliers, staffing models, and customer concentrations differ. A prescribed control may fit the global bank and overwhelm the regional provider. The same control may be too weak for the global bank because complexity creates failure paths that the prescription never considered. Firm-owned evidence creates active accountability. The entity can no longer rely solely on the defense that it followed instructions. It must say, given our technology and operating model, this is how we protect the outcome. These are the measures we trust. These are the assumptions behind them, and this is how the system responds when those assumptions fail. Ownership does not mean self-certification without challenge. The supervisor tests whether the QOQM tree is complete, whether metrics lead or lag harm, whether evidence comes from real operation, and whether weak capability areas are being addressed. The design space belongs to the firm. The burden of proof remains with the firm. The left side of this slide shows the static snapshot. A policy document, an attestation, or a board minute can confirm that a decision occurred. It cannot show whether the organization learned. The right side shows the active loop, where incident data and operating evidence drive capability changes, which in turn alter the next cycle of performance. A loop-based examination asks for the last several incidents or near misses at a boundary. It then traces what changed in govern, assure, plan, design, change, execute, or innovate. The supervisor is looking for causal continuity. Did the evidence reach someone with authority? Did that person make a decision? Did the decision alter a pattern, threshold, runbook, supplier arrangement, or resource allocation? Was the change tested afterward? The FDA Sentinel initiative provides a useful external example of a regulator building a more active evidence system. Sentinel uses a large distributed data network to monitor the safety of regulated medical products after they reach the public. It does not eliminate pre-market review or formal reporting. It adds the ability to query real-world data for emerging safety signals. The broader lesson is that regulation becomes more adaptive when evidence continues to flow after the original approval or assessment is complete. Snapshots still matter. They establish a record and provide accountability at defined moments. The mistake is treating the snapshot as proof that the learning system is active. A mature supervisory posture uses documents to reconstruct the loop, not to avoid examining it. The reservoir image shows how several regulatory demands can draw from the same operational record. Cyber frameworks, operational resilience standards, and continuous improvement rules may use different vocabulary, but they often need evidence from the same incidents, decisions, patterns, and QOQM measures. Without a unified reservoir, each demand creates a bespoke evidence package. The cyber team prepares one narrative. The continuity team prepares another. Internal audit requests a third. The regulator receives several polished versions of the same event, none of which necessarily match the record operations used to run the service. A unified operational reservoir changes the incentive. The organization maintains a single trustworthy record because it supports daily decisions and external assurance. Incident records identify the boundary and affected outcome. Decision logs show who acted and why. Pattern updates show what changed. QOQM structures show whether the change improved the protected outcome. This does not mean every audience sees every record or that confidentiality disappears. Evidence can be governed, filtered, and shared according to authority. The point is that the underlying truth is generated once by the living system, then reused. Reporting burden falls because the organization stops rebuilding reality for each recipient. Assurance improves because the evidence has operational value before anyone asks for it. A supervisory agency cannot credibly demand learning behavior while operating through a static internal model. The agency is also a digital value stream. It receives signals, interprets evidence, allocates examiner attention, publishes guidance, and changes supervisory practice. Those activities have boundaries and feedback loops of their own. The agency should therefore ask the same questions internally. Which supervisory boundaries matter most? How quickly do field signals reach policy owners? What evidence shows that guidance changed because the agency learned something? Which minimum viable capabilities are weak when a novel technology or concentration risk appears? The FDA Sentinel example matters here as well. The initiative did not merely impose a new reporting obligation on manufacturers. It expanded the agency's capability to observe safety signals through a distributed data system. The regulatory institution changed its own evidence architecture. That internal change made a different kind of oversight possible. Modeling the discipline creates a credibility multiplier. Regulated entities may still disagree with findings, but the debate becomes more productive when they can see that supervisory expectations evolve from field evidence rather than from institutional habit. The regulator is no longer asking firms to learn, while keeping its own operating model fixed. The final slide reduces the architecture to 3 fundamental shifts. First, anchor at boundaries. Regulation must identify the explicit points where people, markets, or public systems can be harmed. Context gives legal intent operational meaning. Second, specify capabilities. The 7 minimum viable capabilities replace the assumption that a rigid list of activities can guarantee an outcome. The regulator still requires evidence, but it must demonstrate that the organization can govern, assure, plan, design, change, execute, and innovate within the protected boundary. Third, supervised loops. The examination looks for active learning and adaptation. It asks whether operating evidence changes the system before the same failure returns. Continuous response matters more than a perfect point-in-time picture because the environment will continue to change after the examination closes. Together, these shifts redefine outcome-based regulation as an operating discipline rather than a policy slogan. The test is not whether a regime uses the language of outcomes. The test is whether the supervisory design can trace statutory intent to a boundary, from the boundary to evidence, from evidence to capability change, and from that change to a better public result. That is the standard this chapter leaves with the regulator. Do not ask only whether the regulated entity completed the required work. Ask whether the system can protect the people and institutions the law was written to serve, and whether both sides of the supervisory relationship can prove that the system learns.